Imagine you're a pirate seeking your fortune on the unforgiving seas. You're given a mysterious treasure map, but instead of an X marking the spot, you find a circle showing the region where the treasure could be found. This is the essence of confidence intervals, not just a single point, but a spectrum of potential truths. Hi, I'm Matthew Courtney, and here we talk all about education research and data. So if you're into that, be sure to subscribe to this channel and come be a part of our community. Confidence intervals are fundamental in statistics and research. They offer a range of values grounded in data where a parameter is likely to fall. Many statistical tests will provide both a point estimate and a confidence interval. And while a point estimate provides a specific value, a confidence interval gives a range where this value is likely to lie within a certain level of confidence. Interpreting the confidence interval is pretty straightforward. If we say there's a 95% confidence interval that an average test score improvement is 5 to 10 points, written like this, parentheses 5, comma 10, close parentheses, it means we are 95% confident that the true average improvement falls within this range. We can adjust our range by adjusting our confidence interval. A 95% confidence interval is going to have a little more uncertainty than a 99% confidence interval. Let's take a look at how we might interpret a confidence interval in a more specific school-based example. Suppose a school introduces a new teaching method and wants to measure its impact on students' grades. After evaluation, the average improvement is 8 points, with a 95% confidence interval of 6 to 10. This implies that while 8 is the best estimate, the school's fairly confident the true average improvement is somewhere between 6 and 10 points. As evidence-based decision makers, confidence intervals are really handy because they help us promote transparency and caution. Instead of just claiming a teaching method improves scores by X number of points, a confidence interval shows the range of likely improvements. This nuance helps us to make more precise and informed decisions. Remember, a 95% confidence interval doesn't mean that there's a 95% chance that the true value is within the interval. It means if we conducted the study multiple times, we'd expect the confidence interval to capture the true value about 95% of the time. Let's turn now to a spreadsheet so I can show you how to calculate the confidence interval. Here we have a distribution of 25 random scores. Now, a confidence interval isn't very useful without some other statistics to examine, so I've already calculated the mean and standard deviation here. I've modeled how to do that in other videos in this series in case you need help. We're going to use the CONFIDENCE.T function to calculate our confidence interval. To do so, we'll select an empty cell, type an equal sign, followed by confidence.t, open parentheses. Inside the parentheses, we will type 0.05 to signify our confidence level, and then type a comma. Next, we will select the cell housing our standard deviation and type another comma. Then we will type 25 because we have 25 values in our distribution. Close the parentheses and hit enter. This will give us our margin of error. To find the lower and upper bounds of our confidence interval, subtract and add this margin of error to the mean, respectively. Next time you come across a confidence interval, remember that it's not just any range of numbers. It's a powerful tool that helps us to navigate the uncertainties of data with more precision and confidence. If you found value in this video today, make sure you like and subscribe, and check out some of the other videos in this playlist. I'll see you next time.